Now we will study image formation by a plane mirror. That means we are going to keep an object in front of a plane mirror. The rays from the object will strike the mirror and will get reflected. After reflection, the image will be formed. In this video, we will be studying how the images are formed and what are the characteristics of the image. That means whether the image is real or virtual, magnified, diminished, same size. We'll talk about the location of the image and we'll talk about some other characteristics of the image. So the first topic we are doing is the image of a point object. So we have a plane mirror, and what I am doing, I am keeping a point object in front of a plane mirror. So before starting the ray diagram for the plane mirror, I'll tell you the rules for the reflection of light which we studied earlier. If I have an incident ray striking the plane mirror obliquely, so what I'll do, I'll find out the point of incidence, and at the point of incidence I will draw a normal and then I will draw a reflected ray measuring the two angles. That means incident ray, normal and reflected ray, all three lie in the same plane, you can see, and angle of incidence will always be equal to angle of reflection. So this is the one rule we have to obtain or we have to follow. When the ray strikes the mirror obliquely, we have to draw the normal and then draw the reflected ray with the same angle, right? So this is the reflected ray. Or if the ray strikes the surface normally, then it is going to retrace the path. Okay, so using these two rules, we will try to form the image of a object placed in front of a plane mirror. Remember these two rules. So what do we have over here is a point object O. So from a point object, infinite rays can come. We can draw infinite rays from object, but we have to consider only those rays from the object which are incident upon the mirror. And for the formation of any image, whether the rays meet actually or whether the rays appear to meet, we need at least two rays. So from any point object, we have to consider at least two or more rays. So what I will do in this case, that I will consider one of the ray purposely incident on the mirror. How it is incident on the mirror? It is incident on the mirror normally. Other ray I will consider that these rays are incident obliquely on the mirror, right? So obeying the laws of reflection, I will try to get the reflected rays, and the point where the reflected rays meet or appear to meet is the location of the image. So what if the ray is incident normally? Can I say if the ray is incident normal, it will get reflected along the same path? What if the ray is incident obliquely? So what I will do, I will draw the normal at the point of incidence, and I will try to draw a reflected ray with the same angle of incidence, right? And again in the third case, for this ray with double arrow, what I will do, I will draw a normal and I will draw reflected ray like this. So these are the reflected rays. Can you see them meeting? No. That means the reflected rays are not actually meeting over here. So what I will do, I will just extend them backward. Let's see if they meet. If I extend them backward, what I can see that these rays appear to meet at a point, right? So we have a point object O over here, and the rays from the point object, after reflecting from the mirror, the rays appear to meet at a point. We will say at this point image is formed. So I would name this image as the O dash, which is the image of a point object O. So we can say that the image is formed behind the mirror. This is one of the characteristic. So where is the image formed? The image is formed behind the mirror. Is the image formed due to actual intersection of the rays? No, the image is not formed due to actual intersection of the rays. In fact, it is formed when the rays appear to meet at a point. So definitely this image will be a virtual image, and as I said, virtual image is always upright or erect. So we studied three characteristics about the image formed by a plane mirror: that image is formed behind the mirror, it is virtual, it is erect. One more thing I would like to tell you, that in this case by geometry, okay, the distance of the object from the mirror, that means this distance would be same as this distance. That means the distance of object from the mirror would be same as the distance of image from the mirror. So we have got four characteristics about the image from the plane mirror. First is the image is formed behind the mirror. Second, we can say since image is not formed due to actual intersection, so image is virtual. Virtual is always erect, and the distance of image would be same as the distance of object from the mirror, right? But if you try to draw it or by obeying the laws of reflection, there can be a case where the object and the image distance will not be equal. So in order to draw it properly on your notebook, you have to follow certain rules which I am going to tell you. So what you have to do over here is that we already know that the image is formed exactly at the same distance as that of the object, right? So what I am doing, I am taking an object, let's say this object is at a distance of 5 centimeter from the mirror, right? So let's say this distance be 5, if this distance is 5 centimeter, then this distance has to be 5 centimeter. So on a normal drawn on the mirror, remember on the normal drawn on the mirror, or if you see on your notebook, right, there are so many horizontal lines, right? See, this is very important. So this is the mirror, let's say this is the mirror. So what you do, on one of the horizontal line, let's say on this line, I have considered this point at a distance of 5 centimeter. So this point object O lies at a 5 centimeter from the mirror. So definitely its image will be at a distance of 5 centimeter from the mirror. So I will take image O dash, means I have already located the image O dash, which is 5 centimeter from the mirror. That means this distance will be equal. So what you have to do over here, see, I am telling you the steps to form this image properly. So I have considered a point object O at a distance of 5 centimeter. What I will be doing, I will be drawing a ray normal to the mirror, and I will be extending it, right? Extending it till 5 centimeter, and I already know that the image will be O dash. I will consider another ray, see this ray, right? And I will consider this ray also. So these are the two rays which are incident obliquely on the mirror. So what I will be doing, I will be doing normal for them. So this is the normal. Now we know that after reflection they will get reflected in this way, but if I extend them backward, they will definitely meet at this point. So for construction, what I am doing, that I am already joining point O dash with this point. See here. And now I am extending the ray. Can you see? Now, see, this was the incident ray and this is the reflected. Definitely this angle must be equal, and if I join these 2 points, you can say so definitely this is the reflected ray and this is the incident ray, and this angle must be equal. So in this way you can correctly construct this figure on your notebook. So remember what steps you have to do. You have to draw a mirror, you have to take a point object at a particular distance on a horizontal line, and on the same line at the same distance you have to consider its image. Now since this is the real ray, right? See, this is the real ray which is incident on the mirror. Now after reflection the ray will get reflected along this. So any ray drawn behind the mirror will be shown by dotted lines, because all these rays are virtual rays or imaginary rays. Remember, the complete rays, this ray, these are actually real rays and they are not meeting at any point. But if I extend them backward, they are meeting behind the mirror, right? So this is the way to form the image of a point object. Now in the second case, I will be consider an extended object. So in the next case I will consider, come on tell me, extended object. So for an extended object, let's see what we have to do. I will draw it rough, okay, and then I'll explain the formation of it. So this is a mirror where you have considered an extended object. See, this is a line and we have to form the image of this extended object by reflection of light from the plane mirror. Can I say, name this point as AB? So AB is the object, and between A and B there are so many points located, right? And if I can draw, or if I can locate the image of each point, if I can locate the image of each point, that means ultimately I would be getting the image of object AB. Am I right? But what I have to do in this case, that of the object AB I will consider only extreme points, that means point A and point B. Remember, there are so many points between A and B, but we will show the construction only by the extreme points, and considering that the corresponding images will be formed between A and B. So now what I am doing, that I have got 2-point object. Do you remember? Can you see this as the point object? See, A is a point object, right? And B is also a point object. Using the same rule as that of a point object, we have to locate the image of object A as well as B to get the image A dash B dash. So what you will do, you will draw a normal line, right, where you will extend it and you will construct a point A dash. You will draw 2 inclined rays, and from here you will be continuing the ray and you will be taking it backward, right? So A dash is formed, and same rule for B. What you will do, you will draw 1 complete ray, you will draw 2 inclined rays. So the image of B will be B dash, right, by this method, right? Now since A and B is an extended object, so the image will definitely be like this. So remember, this image we have to shown it by dotted lines because this is not a real image. So what I have also studied, let's suppose it denoted a letter P. So what I have obtained over here, something like this, right? So if I talk about, this is the object, this is the image. So let's talk about some characteristics of the image. So this image is formed behind the mirror, right? It is formed behind the mirror. This image is not formed due to actual intersection, so it is a virtual image, and virtual image is always erect. You can see letter P, okay? The head of the P is present over here also, in the image also. So this image is erect, it is virtual, it is at same distance from the mirror as that of the object, and most importantly, the letter P seems to be inverted. So this phenomena you must be knowing in the plane mirror, where the right of the object seems to be the left of the image. That means if you shake your right hand, it will be your left hand in the mirror. That means this phenomena where the right of the object seems to be in the left of the image is called as, come on tell me, lateral inversion. We talk about lateral inversion. So now we know some characteristics about the image formed by plane mirror. So where it is located, it is formed behind the mirror. It is always virtual, erect. It is always virtual, erect, at same distance, and image is laterally inverted. And one more important thing, that the size of the image will be same as that of the size of the object. That means there is no magnification. That means image is neither magnified nor diminished. In fact, the image will be of same size. So if I talk about the characteristics, I can say, first of all, let's talk about position of image. Where it is formed, come on tell me. Image is formed behind the mirror. And if I talk about some characteristic, so characteristic, you can say, sir, image is virtual, it is erect, the image is of, come on tell me, same size, at same distance, and most important, it is laterally inverted. Image is laterally inverted. I'll show you the method how to draw, how to construct this image on your notebook. So what you have to do, that you have to draw a mirror and you have to consider only 2 points, A and B. So on one of the horizontal line, you can mark point A, right? Whereas on another horizontal line, let's say this A be at a distance of 7 centimeter for example, and consider another point B which is at a distance of, let's say, 4 centimeter or maybe 5 centimeter. Remember, we have to draw 2 times the image of the 2-point objects A and B, for which you will get the image of an extended object. So following the rules, let's say one of the ray will incident normally and will get reflected. So what I will be doing, at a distance of 7 centimeter, I will locate A dash, right? And other 2 rays I have to take it obliquely. Now what I will be doing, I will be joining this A. First let's draw the normal over here. Okay, so I will be drawing this ray, joining this ray with this point. Remember, this will be the imaginary ray and this will be the reflected ray. This will be the imaginary ray and this will be the reflected ray. So what you have obtained the image of point A, that is A dash, right? In the same way, to get the image of point B, which is B dash, you have to follow the same rule. Draw one of the ray perpendicular to the mirror, right? If it is a distance 4 centimeter, now trace it backward till 4 centimeter. Now this is B dash. Now in the same way, construct 2 oblique rays, this one and this one, right? And you have to join this point with this rays. But remember, this should be imaginary. Continue. This should be imaginary till mirror and then continue. So incident ray, reflected ray, incident ray and then reflected ray. I will draw a normal also over here. What we can see that you have located image of A as A dash, image of B as B dash. So if this is the object AB, we can see that this is the extended object, right? So this will be the extended image A dash B dash. So in this way you have formed the image of an extended object, and if it denotes the letter P, you can show like this. Thank you.